Folks, welcome to our help video on the oxidation reduction reaction quiz or assessment 8-19. As we go through these questions, if you need any additional help, do not hesitate to email the question. We can work together, we can set up a meet or whatever we need to do to make sure that you're understanding what we're doing. So just let me know which ones you're having difficulty with. On this first group of questions, we're assigning oxidation numbers or oxidation states. Remember, of course, that oxidation numbers or states are just kind of made up numbers. They don't have actual physical meanings. Unless, of course, you're assigning an oxidation number for an ionic substance, then it does have a meaning, sort of. It's telling you how many electrons it's gained or lost during the chemical reaction. But with respect to molecular compounds, they're just saying, oxidation numbers are just saying who is controlling the electrons. On this first one, they want to know the oxidation number of nitrogen in N2O, dinitrogen monoxide. When we assign numbers, remember that the element that has the higher electronegativity automatically gets its number. So oxygen's a 3,5, nitrogen is a 3,0, so oxygen will get its number. Oxygen prefers 2 electrons in order to get stable. It's in family Roman numeral 6. It needs 2 electrons to satisfy the octet rule, so we assign it an oxidation number of -2. Overall, N2O is a neutral compound. So the oxidation numbers of every atom in that substance, they must add up to 0 since it's neutral. So if oxygen is a -2, as we see here, that means the nitrogens must add up to +2. Very often we write the +2 on top and the -2 on top up here. Do the total charges on top, do the individual charges directly above the atoms on the line underneath, but it can also be down here. So if the oxygens, we have one oxygen at -2, the nitrogens must add up to +2. We have 2 nitrogens adding up to +2, which means each nitrogen must be assigned an oxidation number of +1. That's letter AB. In our next question, we're dealing with sulfur in the sulfate ion, SO4. The sulfate ion is SO4. It is a polyatomic. It does have a charge of 2-. So that means the oxidation number totals must add up to -2. They need to add up to -2. Sulfur's electronegativity is 2,5, oxygen's 3,5, so oxygen will get its -2 number. In fact, oxygen being the second strongest atom will always get the -2 unless it's with other oxygens, if it's in the peroxide ion, or if it's with the only atom stronger, fluorine. So oxygen gets its -2. We have 4 oxygens. -2 times 4 is -8. The oxidation numbers must add up to -2. Here they wrote 2-. No. That's backwards. 2- is the charge. We want this to be -2. The oxidation number is -2 because the charge is 2-. The oxidation numbers must add up to -2. So what do I add to -8 to get -2? That's a +6. We only have 1 sulfur here, so the sulfur would have to be +6. If we had 2, they would be +3. If we had 3, 6 divided by 3, they would be +2. If we had 2, they would be +3, but we only have 1. +6 divided by 1 means the sulfur is +6. That's letter A. The next one, we're assigning oxidation numbers to chromium in potassium dichromate. Cr2O7 is the dichromate ion. If you remember, the dichromate ion itself is 2-. It is a polyatomic ion. The Cr2O7 is 2-. The potassium is an alkali metal. It is always 1+. So when they wrote the formula K2Cr2O7, they crossed the 2- from the dichromate down to the potassium. They crossed the 1+ from the potassium down to the dichromate. That's why there's no parentheses around the dichromate ion. So let's begin assigning oxidation numbers. They want the oxidation number of chromium here in this compound. Who gets the number first? Oxygen. Oxygen has electronegativity of 3,5. It's going to get its number of -2. We have 7 oxygens at -2, so their total's -14. If you remember our assigning, potassium, the alkali metals, other than hydrogen, always get a +1. It's the only thing they can be. We have 2 potassiums at +1, so their total's +2. Overall, potassium dichromate is neutral. The potassium's cations offset the dichromate anion, polyatomic anion. So the oxygens are -14. We have 2 potassiums at 1+. They're +2. If we take -14, add 2 to it, we get -12. That means the chromiums must add up to +12. The chromiums must be +12. We have 2 chromiums that are +12 total. So each chromium is 6. So the potassiums add up to +2. The chromiums are +6 times 2, that's +12. 2 and 12 is 14. The oxygens are -7 times 7, that's -14. Overall, we have a neutral. So the chromiums are +6. That's letter A. Number 4, what's the oxidation number of oxygen in Na2O2? Holy cow, Na2O2. This is a little bit of a tricky one here. Na2O2. When we have a 2 after the oxygen, we have to suspect that it could be the peroxide ion. The peroxide ion loves to hang out with sodium, family 1 metals. It just loves to. This is sodium peroxide. So we don't immediately assign the oxygen a -2. It's the peroxide ion. Now, we could just look at the peroxide ion by itself. The peroxide ion is O2, and overall its charge is 2-. We have 2 oxygens in the peroxide ion, so each oxygen atom in the peroxide ion is 1-. That means it has to have an oxidation number of -1. Remember, the oxidation number will always equal the charge of an ion. So right away, we know the oxygen is a -1. That's letter AD. Or we can work the whole thing out. Again, it's not it's not oxygen atoms. So we're going to have to assign sodium its +1. Sodium always gets its +1. We have 2 sodiums at +1. They're +2. Overall, Na2O2 is neutral. So what do we have to add to +2 to get 0? The answer is -2. So we have 2 oxygen atoms adding up to an oxidation number of -2. That means each of them are -1, as we already know. Number 5, what is the oxidation number of bromine in Br2, Brinkelhoff? Well, we only have 1 bromine here. We only have 1 substance here. It's bromine. This is elemental bromine. Elements cannot hog electrons. Remember, oxidation numbers are trying to tell you who has control of the electrons. You can't control electrons from another atom that is the exact same as you. You have the same electronegativities. There's no hogging going on. So the BRs are 0 oxidation number, and that is letter AC. That is letter AC. And we are done with the first 5. Which one of the following numbers, oxidation numbers, is incorrectly assigned? Letter A, the hydrogen's fine here. The hydrogen's going to be a -1. When hydrogen's with the metals, it is always a -1. Remember, the alkali metals will get their charge. They're +1. Their oxidation number is +1 because their charge can only be 1+. Nitrogen here is electronegativity is 3O. It's the third strongest, so it gets its -3. So we have 3 hydrogens that are going to have that total +1. 3 times +1 is +3. Right here, PO3 3- in the phosphide ion. The oxygens get their -2. We've got 3 oxygens at -2 for a total of -6. The charge of this thing is 3-, so the oxidation numbers must add up to -3. Again, they wrote the 3- here. I would prefer if they wrote -3 because the oxidation number has to equal the charge. That means the phosphorus must be +3. +3 minus 6 is -3. Aluminum ion, this is a monoatomic ion. If you look in your rules, monoatomic ions, the oxidation number equals the charge. So it's +3. Number 4, fluorine always gets a -1 unless it's with another fluorine. When a fluorine's with fluorine and F2, its oxidation number is 0. We have 6 fluorines at -1. So -1 times 6 is 6-. That means the sulfur must be, or 6 minus 6, that means the sulfur must be +6. Okay, we've got a problem here on this one. We know fluorines are going to be zeros. We know fluorine by itself is a 0. You can't hog electrons from yourself. We know the barium by itself is a 0. It's elemental barium. So the answer is AB, but let's see what's wrong with AB. They've assigned the sulfur a -6. Well, oxygen gets its number. Its number's -2 because oxygen's electronegativity, second strongest at 3,5, sulfur's 2,5. So we get oxygen at -2. We've got 3 oxygens at -6. Overall, this is the thiosulfate ion, which is 2-. Overall, it needs to add up, the oxidation numbers need to add up to -2. Again, they wrote the 2- here. That minus should be over here. -2. So if the oxygens add up to -6, that means the sulfur would have to be +2, because 2 sulfurs at +2 is +4. +4 minus 6 is -2. So the sulfur can't be +6. If the sulfur was +6, we would have 2 sulfurs at +6. That would be +12. +12 minus 6 is nowhere close to the -2 it needs to add up to. So they have the sulfur wrong here. The oxygen is -2. The sulfurs are going to have to be +2. We've got 2 of them for a total of +4. Number 7. Which one of the statements is incorrect? Look at letter E here. The least electronegative element will be assigned an oxidation number equal to its charge when ionic bonding. No. The most electronegative element automatically gets the charge it would acquire when it was forming an ionic bond. So fluorine always gets its -1. Oxygen always gets its -2. The more electronegative elements are assigned the charge that they would have when bonding. The least electronegative element in the compound will be whatever charge it needs so that the charges balance out to what they need to be. Number 8, what is the stock name of P4O10? What is the stock name of P4O10? Stock name's the one that uses Roman numerals. So one of the uses of oxidation numbers is to determine stock names. What's the charge of the first element? So here we have oxygen. Its electronegativity is 3,5. Phosphorus is only 2,1. So oxygen gets its number of -2. We have 10 oxygens at -2 for a total of -20. P4O10, tetraphosphorus decoxide, is the name of that using prefixes. The phosphorus would have to add up to +20 because P4O10 has no charge. We have 4 oxygens adding up to +20. 4 phosphoruses adding up to +20 means that each phosphorus would have to be +5. So the stock would be phosphorus 5 oxide. When you use the stock name, there are no prefixes. The next video will discuss the reactions